Good morning, girls. Now, I have got a request to discuss two topics, that is perfect number and twin prime numbers, not twin numbers, twin prime numbers. I will start with that and then I'll do something new. To discuss. Okay, I'm just repeating again that you can put in your doubts either in your group chat or in the live chat. Perfect numbers. Now take example of number 6. Okay, I'm first discussing perfect numbers. For example, 6. Now let us see what are the factors of 6. I'm discussing perfect numbers. Okay, 6. What are the factors of 6? Now how do you find out factors? Just I'm going to make pairs which when multiplied gives you 6, like 1 into 6, then 2 into 3. You cannot divide 6 by 4, so you don't have anything. Then you have 5 is not divisible, then comes back 6, so again you have 6 into 1. Now see, not this way, I will not do this. After 2 we will have 3, right? 3 into 2. Now 3 into 2 is same as 2 into 3. I'm not getting any new factor from this pair, so I will not consider this. Okay, because I'm getting the same thing, so I don't have anything new. When the pairs start repeating, see 2 and 3, this is 3 and 2, the pair is same, so that means don't have anything new factors. So the factors of 6 are factors of 6 are 1, 2, 3, 6. Now let us find the sum of the factors. What are the sum of the factors? We will add all the factors. Okay. 1 plus 2 plus 3 plus 6. What do you get? You get 12. Now see, this is the original number. This is original number n. Now this sum of factors is same as, this can be written as 2 into n, right? 2 into 6. This is 6 is the original number. So 2 into n. So the sum of the factors is equal to twice the number. So what do we get? Sum of factors is equals to twice the original number. Okay, such numbers are called perfect numbers. I'll take another example. I hope this is clear. How do we do it? Let us do another example. Suppose the number given is 16. Okay. So what are the factors of 16? How will you get 16? 1 into 16 is 16. 2 into 8 is 16. Then 4 into 4 is 16. Then 5 is not a multiple, 6 is not a factor, 7 is not a factor, again 8 into 2. So you see, this pair and this pair is the same, so that means we don't have any new factors. This is all that we have. So what are the factors of 16? 1, 2, 4, 8, 16. 1, I'll give a comma now. 1, 2, 4, 8 and 16. These are the factors of 16. Now let us find the sum of the factors. Let us add 1 plus 2 plus 4 plus 8 plus 16. So how much are we getting? 8 plus 2, 10, 10 and 4, 14, 14 and 1, 15. 15 plus 16, which is equals to 31. Now see, this is not equals to twice the number. What is twice the number? Twice the number is 16. So twice the number is 32. So the sum of factors is not 32. It is equals to 31. So here sum of factors is not equal to twice the original number. Twice the original number. So this is not a perfect number. Okay. So this is, therefore 16 is not a perfect number. So 16 is not a perfect. So if you have space over here, you write. Okay. I don't have space, so I'm writing here. Not a perfect number. Okay. Let us do another one. Let's take n equals to 28. N equals to 28. So what are the factors of 28? 1 into 28, 2 into 14, 4 into 7, 7 into 4. So repeating, so we stop. So the factors are factors of 28 is equals to 1. How are we seeing it? How do we write? 1, 2, 4, 7, 14, 28. Okay, in this way we will write 1, 2, 4, 7, 14, 28. So let us find the sum of the factors. You will write the sums in your copy when you get such sums to prove whether the number is a perfect number or not. You will write it in this way that I am writing for this question. Sum of factors is equals to 1 plus 2 plus 4 plus 7 plus 14 plus 28, which will be summing up to 56. Okay. Now what is twice the number? Twice the number is also equals to 56. It is 2 into 28, which is equals to 56. Therefore, sum of factors is equal to twice the number. Okay. Therefore, 28 is a perfect number. Okay. Yes. I've got some response from few students here. Yes, this is your classwork and this has to be done in the copy. Okay. Now I will do twin primes. Those who want to copy in your exercise books, you can. Okay. You might need it for later reference. These examples you might need. So you can copy in your exercise books if you want. Now comes twin primes. Okay. hope you know what are prime numbers. What are prime numbers? Prime numbers are those numbers which have only two factors, 1 and the number itself. Okay, so suppose 3 is a prime, 5 is a prime, 7, then 11, then 13, then you have 17, 19, um, 23, in this way. Okay, some of the first few prime numbers. Have I missed any? 3, 5, 7, 11, 17, 19, 23. Okay, now let us take 3 and 5. Both are twins. And what is the difference? What is the difference? That is, if you subtract 5 minus 3, what will you get? 2. Okay, so 5 minus 3 is 2. So we say that 3 and 5 are twin primes. Two prime numbers whose difference is 2 are called twin primes. Now if you take 3 and 7, what is the difference? 4, right? So they are not twin primes. Again, if you take 5 and 7, 5 and 7, again the difference is 2, right? So they are twin primes. 3 and 7 are not twin primes. Both are prime, but their difference is not 2. Difference is 4. So they are not twin primes. Now if you take now 5 and 11, the difference is what? 11 minus 5 is 6. So they are also not twin primes. Then if you take 7 and 11, they are also not twin primes because their difference is 4. Then, but again, if you take 11 and 13, their difference is 2, right? So they are twin primes. Then 11 and 17, they are not twin primes. 13 and 17 is also not twin primes because here all the difference is either 4 or 6. Again, if you take 17 and 19, they are twin primes. Their difference is 2. Both are prime and their difference is 2. Okay, so in this way you decide whether they are twin primes or not. I hope it is clear. Nikita had given this question, so I hope, Nikita, these two concepts are clear by now. Now we will start the exercise 4.1. Question number 1 and 2 I will discuss and send it to you. Okay, we will start with question number 3. Write all the factors of the following natural numbers. Question number 3, subpart 1. Let's try subpart 1. So 68. So what numbers when multiplied will give you 68? 1 into 68 will be 68. Now see, it is an even number, right? Because it is ending with 8. So it is divisible by 2. So in the rough column, this is my rough column. Rough work. I can divide 68 by 2 and see. If you can do it mentally, it's very good. But you are not able to do mentally, then you can do it in the rough work. Okay. So 34. So 2 into 34 will give you 68. Then 3, will it be a multiple? You have to divide and see here. 3 2s are 6. Again 3 2s are 6. Uh, 3 2s are 6. Remainder is 2. So this is not a multiple. So you cannot do it with uh, 3 anymore. So in this way, by trial and error, we have to go on seeing that is it a multiple or not. So next we try with 4. 4 ones are 4. So yes, it is. 4 into 17 will give you 68. After these trials and errors, it is not divisible by 5 because it is not ending with 5 or 0. Now it is not divisible by 6 because it is not divisible by 2 and 3 both. It is divisible by 2 but not divisible by 3. So we cannot see. So in this way I will see again, I will get back to 17 into 4. So since it is a repetition, I will stop. So what are the factors? Factors of 68 is equals to 1, 2, 4, 17, 34, 68. Okay. Next we will do question number 4. 4 subpart 2. First 6 multiples. Multiples means you have to multiply and find out. Multiples. 1 times, 2 times, 3 times, and these are multiples of 5. First 6. So 5 ones are 5. 5 twos are 10. 5 threes are 15. 5 fours are 20. 5 fives are 25. And 5 6 are 30. So these are the 6 multiples of 5. So the answer is 5, 10, 15, 20, 25, 30. Okay. In this way you have to write the answer. You have to show the working properly. Even if you can do it mentally, you please show the multiplications. Similarly, for 4 subpart 1 and 4 subpart 3, it will here you will write 3 into 1, 3 into 2, 3 into 3, 3 into 4 in this way. Okay. Next we will do question number 5. 5 subpart 1. What is the 7th multiple of 36? 7th multiple means you have to find out 36 into 7. This is the 7th multiple. If they give you 8th multiple, then you will multiply with 8. Okay. So this you can do in the rough work or mentally also you can do it. 7 6 are 42. Carry 4. 7 3s are 21. 21 and 4 is 25. So 252 will be my answer. Okay. Question number 5 subpart 2. the even multiples of 9 less than 100. Even multiples. So for 9 you have odd multiples and even multiples both. So you have to write only the even ones. So that means now you know that 9 ones are 9. See, 9 ones are 9. 9 twos are 18. Again 9 threes are 27. So these are the even multiples. So 9 twos are 9 fours are in this way. I will write down the even multiples of 9. Even multiples of 9. So 9 twos are 18, 9 fours are 36, 9 six are 54, but it has to be less than 100, okay? 9 eights are 72, 9 nines are 81, 9 tens are 90, 9 elevens are 99, 9 twelves are 108. So this will be my final answer. So the answer is 18, 36, 54, 72 and 90. I hope I've not missed any one of them. Okay. Yes. Next we will do 5 subpart 4. Now 5 subpart 3 you can do on your own for your homework. First 3-digit even multiple of 7. First 3-digit even multiple of 7. Okay. So multiples are always greater than 7. Now first 3-digit means it is close to the lowest 3-digit number. So which is the smallest 3-digit number? Smallest 3-digit number is equals to 100. Now what are they asking? That a multiple that comes after 100. Multiple of 7 after 100. The first one which comes after 100 is your answer. First they are saying. Okay. Now 3-digit number starts from 100. So what we are going to do is we are first going to divide 100 by 7. Okay, I can do it here also. It's because it's a very important calculation. So I will do it here. So first I am going to divide 100 by 7. Okay, 7 ones are 7. Remainder 3, 0 comes down. 7 fours are 28. Remainder is 2. So 14. Now what does this mean? This means that a multiple which is multiple of 7 here, 7 into 14 is somewhere before 100. 2 extra, no? 2 extra. So that means 98. Now I have to find out the multiple which is after 100. So obviously it should be 7 into 15, isn't it? Because 7 into 14 extra is only 2. So that is 98. I want a 3-digit multiple. So if 14, so the next multiple is 15. So you find out what is 7 into 15. Okay. So 7 into 15 is equals to 105, which is the answer. Okay, sorry, you have to find out the even multiple, right? Sorry, 3-digit even. So this is odd, so this will not be the answer. Let us try the next. 7 into 16. So that should be 112. So the answer is 112. equals to 112. So you can make a box. Okay. Let's go to 5 subpart 5. 5 subpart 5. Multiples of 6 between 40 and 80. So all those numbers in 6 times table which is between 40 and 60. Okay, now we know that 6 6 are 36. 6 sevens are 42. So it should start from 6 sevens are, right? 6 6 are 36 and you are required to write all the multiples between 40 and 80. So it should be more than 40, less than 80. 42. Then let's continue. 8s are 48. 9s are 54. 10s are 60. 11s are 66. 12s are 72. 13s are 78. Definitely if you go to 14 it will be more than 80 because 13 is only 78. So this is 24 and this is 84. So I don't need this, isn't it? It has to be less than 80 and more than 40. So this is your required set. So you cancel this. You can just show the cancellation in this way. These are the required multiples. So answer is equals to 42, 48, yes, you can do the rough work there, but if it is a main part then you can do it in the sum in the fair itself. 54, 60, 66, 72 and 78. These are your answers. Okay, then we will do 5 subpart 6. 5 subpart 6. The greatest two-digit multiple of 5. Now greatest two-digit means near to 99, after which it will become 3-digit. So which is the first 3-digit number? 100. So if you divide 100 by 5, what do you get? 20, right? So 5 into 20 is 100. Now if you do 5 into 20 is 100. Now if you do 5 into 21, it will become 105. So you have to go backwards. So 5 into 19 will be 95. So 95 is your answer. So see, this part you have to do in the fair. This working if you show in the rough column, then what will you do in the fair? So your answer is 5 into 90 is equals to 95. Now let us do question number 6. Question number 6. Oh, I'm so sorry. I will do 5 subpart 6 again. Okay. They asked for the greatest two-digit even multiple of 5. So we know that 5 into 20 is equals to 100. So we have to see which is multiples the less than 100. this is equals to 95. This is less than 100, 2 digit, but not even, so it should be something like this. So it should be 90. So the answer is equals to 90. The previous process was also correct, but only that we missed the even multiple. So it should be the greatest 2 digit even multiple of 100. See, after 100, which is the even multiple, after 90, which is the even multiple, 100. So that is 3 digits. So this will not do. So this is a correct answer. Now I will do question number 6 of part 1. Find the common factors of 20 and 28. Find the common factors of 20 and 28. So let's find out the factors of 20 and 28 first. 1 into 20 is 20. 2 into 10. Then 3 is not a multiple. 4 5s are. Then 5 4s are. Okay, so I will not use this. So that means no more new factors. Then 28. 1 into 28 is 28. Then you have 2 into 14. Then you have 4 into 7. And then 7 into 4. So it's repeating. So I will stop. So let us write the factors of 20 is equals to 1, 2, 4, 5, 10, 20. 1, 2, 4, 5, 10, 20. Then factors of 28. 1, 2, 4, 7, 14, 28. 1, 2, 4, 7, 14, 28. Now let's see what is common, which are there in both the numbers. 1 is there in both. 2 is also there in both. 4 is also there in both the list. And there we don't have any more common factors. So what is my answer? So the common factors are 1, 2, 4. This is my answer. Okay. Similarly, for question number 7, you have to find out the factors of 3 numbers and find out the common factors. So I will do till here today. I will not go any further. I'm giving you 10 minutes to do question numbers. I'm giving you the classwork in the WhatsApp group. You will do a few numbers now, sums now, and show it to me.